migration process, we actually have a flow that in general we follow that, again, I won't walk through all of this, but we end up creating a plan for how you lift individual apps, how you look at, and we do a lot of analysis using automated tools to run against the environment and against the app in order to find out what virtual networks and a whole bunch of other IT, lower level plumbing things are necessary, map those into the future state cloud, validate that, and then ultimately move an app, make sure it works in production. And once we've got the process down in a given application environment, then it's just rinse and repeat. Modernization is always more complex, right? But it's also more worth it because you end up gaining the advantages of being in the cloud. And again, my end goal always is that cloud native is where the true savings are. Right? If all you do is lift and shift, really what you're doing is saying, hey, instead of me paying for the air conditioning and the floor space and the servers, I'm paying Amazon so that they can cover those same costs. And maybe they're able to do it cheaper than I was. Maybe not. There's no guarantee actually that you're going to save any money. And certainly you're not going to reduce your own staff, because you still got to have the same number of people managing all the same servers. It's just that they're running in somebody else's cloud. But here we end up looking at an environment where if I redesign my code, and so this is a well-known thing called 12-factor design that says, hey, if you apply all of these best practices or really design patterns to your software, over the last probably 15 years, these are things that we have observed that good, high-functioning cloud-native software do. And so somebody had asked the question about, boy, suppose my software is ancient, legacy, creaky. It was you, yeah. How do we get there? Because really, most of the existing software that we have, and you guys, I'm sure, can all relate to this in that some of our customers we go into and we're like, so, we've done this whole portfolio rationalization process, and we're like, hey, so can we look at the code for this one particular app? And they're like, yeah, we're not sure where the code is. I think that it's on Beth's computer because she wrote it, but she doesn't work here anymore. And we think the computer's in a storage room. I mean, it's literally at that level sometimes, right? And so it's kind of, so you might be at that level, but hopefully not. But once you find the code, then you find out that it probably conforms to 0 of the 12 factors, right? And so what we've identified is out of these are 5, what we call the fast 5. And so these are the 5 factors that if you're going to do just modernization, not a rewrite, but just to get a legacy app modernized so that it can at least run in a modern cloud environment like Kubernetes or something like that, you need to have the code base. That's step 1. And not only that, you have to actually have the code base in a way that you can apply DevOps to it. So you have to be able to build, release, and run in an automated fashion. The code base has to be maybe altered in a way, and this one can be a big one, in a way that it's what we call disposable, which is to say that the application needs to be able to shut itself down or be shut down and then be able to come back in a graceful way. And I know early in my career, I remember writing lots of software that we just assumed would never shut down. It was just going to run all the time, right? And there's a lot of software like that, so when it does shut down and restart, especially if it's a hard shutdown, there's usually some operations person has to get involved to fix something that, a file that gets corrupted or who knows, right? That can't be allowed to happen, because in a cloud native environment, these cloud fabrics like Kubernetes are self-healing, which is also to say that if they start detecting that a node is going to go down, they will just move all of the instances of software on that node to a different node, maybe even proactively. And they will do it by just shutting you down on the old node. So basically, if your software can't allow itself to be shut down and restarted somewhere else, that has to be altered. You have to overcome that. So that one can be tricky. The next one that's blue up here is configuration. And so most of our old applications use files for configuration. Right? Some sort of text file, INI file, JSON, whatever. You can't use files for configuration if you're in a cloud native environment. For one thing, it was never a very secure option. Right? It was never a good idea to start with. But it turns out that once you're in these cloud native environments, again, we're giving up control of the physical machines and the hosting environments. And so you have to move the config out of files and actually into the runtime environment itself. And so there is a set of code changes that are usually required. Any place in your code that deals with configuration, like getting database connection strings and all sorts of stuff, that will have to be changed. And then finally, logging. Now, a lot of organizations find that their apps, especially older apps, don't have any logging. But again, we're running in a self-healing cloud fabric environment, and being able to understand what's going on at all requires that every application have at least some basic level of logging. And even if your application already has some basic level of logging, it probably doesn't log in a way that is blessed or well understood by your runtime fabric like Kubernetes or Cloud Foundry. And so if you have logging, you're going to have to change it. That's probably the easy part. If you don't have logging, you're going to have to add it, which is probably the harder part. You can imagine the other green boxes are just as sophisticated, right? And if you're going to rewrite your app to be truly cloud native, you want to have all 12.